Hello everyone and welcome to this video. Imagine you're a data scientist at a retail company. Your boss wants you to analyze customer purchasing behavior to improve marketing strategies. The data set is high dimensional with features like age, income, and purchase frequency. To make sense of this data, we'll use PCA to reduce dimensionality while preserving essential information. Let's start by loading the dataset. This dataset contains information about 50 customers, including 6 columns. We'll explore these features to understand our data better. Let me show you how you can load the dataset using pandas. We import pandas and numpy, then use pandas' read CSV function to load our data from a file named dataset.csv. Finally, we display the first few rows to get a quick overview of the data. In this dataset, we have customer details like age, income, purchase frequency, and other relevant features. These will help us understand customer behavior. To understand the dataset better, let's start by examining some summary statistics. This will give us insights into the distribution and range of our data. So let's go ahead and use the describe function from pandas to get summary statistics of our dataset. This will provide us with measures like mean, standard deviation, and range for each feature. Looking at these statistics, we can see some interesting patterns. Customers are mostly young, with an average age of 33.5 years. The average income is $67,240 with noticeable variability. Customers buy 3.5 times on average, and spending patterns vary between online and in-store purchases. The loyalty score indicates strong customer retention. PCA is sensitive to the scale of the data. Therefore, we need to standardize the dataset so that each feature contributes equally to the analysis. We'll use the standard scaler from scikit-learn to achieve this. So what we are doing here is importing the standard scaler from scikit-learn. We create an instance of the scaler and fit it to our data to transform it. This process standardizes the data, ensuring each feature has a mean of 0 and a standard deviation of 1. Now, each customer is described by a vector of length 6 with standardized values. This prepares our data for PCA. Now that our data is standardized, we can perform PCA to reduce the dimensionality from 6 to 2. This will help us identify the principal components that capture the most variance in the data. Let me show you how to perform PCA using scikit-learn. We import PCA, specify the number of components as 2, and fit it to our scaled data. This transforms our data into a lower dimensional space, capturing the most important patterns. Now, each customer is described by 2 numerical values, representing their position in the principal component space. To better understand the results of PCA, let's visualize the data in the new principal component space. This will help us see how the data clusters and identify any patterns that may inform our marketing strategies. So let's go ahead and create a scatter plot using matplotlib and Seaborn. We plot the principal components on the X and Y axes, giving us a visual representation of how the data is distributed in this new space. By looking at this chart, we can see how the data is distributed in the principal component space. Clusters in this plot may indicate groups of customers with similar purchasing behaviors. These insights can guide targeted marketing campaigns. Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.